Our fifth and final matrix lesson is going to involve this process known as Cramer's rule. And Cramer's rule is another way of solving a system of linear equations. Well, you already know three ways. You learned from Algebra 1, and then we've practiced more in Algebra 2, how to solve a system by substitution, by elimination, by graphing. Well, you're going to have another method at your disposal, and a lot of people like this method better than any of the other three. I personally do. If you're dealing with a 2x2 matrix especially, which is what we're going to be dealing with in this lesson, I think this is the easiest of the methods to solve a system. Now, if you do a 3x3 or bigger with a graphing calculator, it's pretty easy, but doing it by hand, it's kind of cumbersome. Wouldn't recommend it. But you won't have to worry about that. We're going to stick with 2x2 matrices, and I'm going to illustrate to you Cramer's rule. Okay, so here is our system. Remember, a system is two or more. In our case, it's going to be two. And they're going to be linear equations. And the goal is to find the solutions for both x and y. A solution for a system is a number that we would plug in for each of these x's and each of these y's, and it would make each of these equations true. If it makes one equation true, not the other, then it's not truly a solution. So our goal then is to find x and y, and we'll write our answer as an ordered pair. So what we're going to do is take this given system, and we're going to write what is known as an augmented matrix. Well, here's what I mean by that. To the left of this vertical line, I'm going to pull out just the coefficients of this system. 3, 2, 1, -1. So I've made a matrix out of the coefficients. We literally call that the coefficient matrix. To the right of the line, you can probably guess, I'm going to put these constants. Constants are numbers without variables. So this is, again, an augmented matrix. It's adding something to a matrix. It's really just one matrix, but you can kind of think of it as a combination of two. We have this coefficient matrix, and then beside that we have this constant matrix. Well, then we begin the step of finding, well, we're going to solve for x and y, but step one is finding the determinant of just the coefficient matrix. I have this capital D, which is going to represent the coefficient matrix. So this is a review of our previous lesson. How do we find the determinant of a 2x2 matrix? Well, I multiply going this way first. I call these the A and the D elements. 3 times -1 is -3. I always subtract when I'm finding a determinant. And now I multiply going this way, the B times the C elements. And I put those together and I get -5 as the determinant of the coefficient matrix. All right, let's move on to step 2. Step 2, I'm going to find what is known as D sub x. D stands for determinant. What do I mean by D sub x? Well, basically what that means is, if you go back and you look at the coefficient matrix that we just used, I have replaced the x coefficients. I just completely replaced them with the constants. Do you see that? If you go back to or look at that slide, I took these constants and I just brought them over and literally replaced the x coefficients. And now I'm going to do another determinant. So these Cramer's rule with 2x2 matrices involves 3 determinants. All right, multiply A times D, 0 times -1, that's 0. Minus, multiply B times C, that's -10. And when I put those together, I get D sub x is 10. Now remember, the goal of solving any system is to find x and y. And a lot of people make this mistake, so listen carefully. I have not found x yet. I have found this determinant called d sub x. Now it's going to be used to help me find x, but it's not my answer for x. My answer for x I'm going to do real fast in step 3. I'm going to take that d sub x number, which is 10, and I'm always, to find x and y, I'm always dividing by that first determinant that we found way back in step 1, that determinant of the coefficient matrix, which was what? Negative 5. Now when I do this simple division, I will have x. X is negative 2. Okay? Well, pure Cramer's rule says to find y, I do basically the same thing, except this time I'm going to find d sub y, which involves replacing the y coefficients. So I take those constants. As you can see, I now have the x coefficients back like they were originally, but I've replaced the y coefficients. And I find the determinant of this. 3 times negative 5, negative 15. Always subtract. 1 times 0 is 0. D sub y is negative 15. Well, to find y, I use that as my numerator, and I always divide by the determinant of the coefficient matrix. So y is going to be positive 3. So my answer, as an ordered pair, we said that x is negative 2, y is 3. And that is Cramer's rule. You would have gotten the same answer if you used substitution, elimination, graphing. If you graph those two lines, they should cross at negative 2, 3. But to me, this is pretty fast, especially when you get used to it. You'll run through these pretty quickly. So what I'd like for you to do is, I went ahead and gave you the answer to shoot for. I want to see if you can use Cramer's rule to find this answer for problem B. Okay, so we begin by coming up with this matrix we call the coefficient matrix. So just pull out the coefficients. The x coefficients, 2 and 1. The y coefficients, 3 and 2. And we find the determinant of this 2 by 2. So 4 minus 3. So the determinant of the coefficient matrix is 1. To find d sub x, I replace the x coefficients with the constants. So this matrix, d sub x, is going to look like this. 5, 6, and I'm going to leave the y coefficients like they were originally, and I find the determinant of this. 5 times 2 is 10, minus 18, and that's negative 8. So to find x, I take my d sub x, and I always divide by this initial determinant of the coefficient matrix. So that's how we got x is negative 8. D sub y looks like this. It's going to be the matrix 2, 1 for the x coefficients, but I'm going to replace the y coefficients with the constants. And I do another determinant. 2 times 6 is 12. Minus 1 times 5 is 5. D sub y is 7. Well, that means y is going to be 7 divided by 1. We always divide by this coefficient matrix determinant. And now you can see how we got 7 for y in the answer. Okay, any questions so far? I'm going to have you try one more, and we're going to see if everybody gets it right. So take a look at problem C. I went ahead and gave you the answer so you'll know if you got it right. But work through Cramer's rule to see if you can solve this system. Okay, so we successfully solved this system using Cramer's rule. We came up with that answer for x and y. And now this is the assignment. We're going to go back. My experience in this matrix unit tells me that probably the most difficult of the problems, if they are difficult, the most difficult type of problem to work with are these problems involving using an inverse matrix to solve an equation. like the homework that we just graded, lesson 4. So we're going to go back, and this is provided for you on RenWeb. We're only going to do these problems, but you need to solve them by using an inverse matrix, just like the homework you had due today. And then, this is what I want to make sure you understand. Today, today's lesson will be practiced with this lesson 5 homework handout. So let me just tell you right up front, some of the instructions are going to say use, I don't know, they might say solve this by using an augmented matrix. Well, that's a different method that I'm not going to cover with you. So here's the bottom line. On this handout, you're going to solve every single problem that's listed using Cramer's rule, regardless of what the instructions say. Just ignore the instructions. I'm afraid I'm going to get an email tonight that says, you didn't cover this in class, so I don't know how to use this method. Well, that's because I don't want you to use that method. I want you to use Cramer's rule for every single one of these. So if the book tells you something different, ignore it. Okay? So I'm going to let you get started, and we'll check these out tomorrow. And if you have any questions when you're working on it tonight, you're welcome to email me.